So, actually, what do we got? 4 weeks left. Would you guys prefer a oh, Keith's coming. I'll wait until he comes in. It's more than half. What's up, sir?
I so forgot.
You forgot? It's cool.
Reminded myself all weekend.
I meant to send an email last night, but I forgot. Too busy watching The Walking Dead. So today's the last day we're going to spend on GD&T, and from here we're going to do welding drawings, and we're going to do threads and fasteners in the last 4 weeks. So would you guys prefer a test on GD&T on Wednesday, or would you prefer having it rolled into the final with the last two things that we're going to do? Keeping in mind you'll probably forget a lot in 4 weeks. So what would you guys prefer?
GDT test, just for GDT.
Yeah, okay. So we'll probably do that on Wednesday, or we will do that on Wednesday. We'll plan on doing that on Wednesday. And then while you guys are working, I'll pull it up and see if I can tell you anything about it. How much of it's drawing and how much of it's questions, I can't recall, so I'll have to pull it up. Friday, excuse me, we're going to take a mini field trip over to the welding lab, because have you guys seen their virtual welder? So they got this virtual welder that's awesome, that lets you put on the hood, and you see, like, you can even pick your environment for where you're at, and then they have what they call a coupon, 2 things that you've got to weld, and then they do wire, they do TIG and MIG, and then it shows you if you're going too fast, or if you move back and forth, or if you need to go closer and further, so you actually get to like do some welding virtually. It's pretty cool. So we're going to go over there, and Mr. Seipert, Greg over there, will tell us a little bit about welding and what they do, and we get a chance to play with that. And then from there we'll get into all the welding symbols and do a few welding drawings next. So that's usually fun. So Wednesday we'll do a test, and then Friday we'll go and do some welding. Then the following week is the following week skills? No. The following week is the 3-day week because of enrollment day and professional learning. So we'll get into welding that week. Yeah, skills is in 2 weeks. Yep. All right. Well, let's talk about the last 2 GD&T symbols that we're going to talk about. It's not the last 2. There's more, but I want to move on to some other things and just cover the majority of them. Like I think I told you at the beginning of this whole unit, we used to have a GD&T class that was 3 credit hours, I think. So we could spend a lot more time on GD&T. But today, I just want to cover a couple more characteristics. The first one being concentricity. So concentric, when we're talking about 2 circles, we're saying that they share the same center point. So when we're looking at concentricity, we're looking at features. So they could be holes, they could be cylinders, and we're looking at how concentric they are with each other. So when we talked about straightness of an axis, for example, it gave us a circular tolerance zone. And it's a very similar idea, except we're talking about the centers of 2 features and how closely together they need to be tied with each other. So we have to have a datum, because we've got to have one feature that's a datum, and then we've got to have another feature that's referencing that datum. And so the datum has to be a feature of size. It can't just be pointing to a surface. I've got to say this diameter 2 cylinder is datum A, for example. And this cylinder needs to be concentric within 2 thousandths to datum A. So here's an example. So once again, remember, if I want to call this out as a feature of size, I've just got to line up the datum symbol with the diameter value. And then this cylinder over here, we're saying is concentric within 4 thousandths to datum A. And again, just seeing what that looks like, I'm basically creating a little tolerance zone, circular shape, that needs to line up with the first feature. So since it's circular shape, again, we'll be putting in the diameter symbol. Any questions on that? Pretty straightforward, hopefully.
Is the datum most likely going to be the bigger one?
Not necessarily. It could be a smaller one.
Okay.
Yeah, it happens to be in this case, but it could be the smaller one. So the other one we're going to look at is symmetry. So we're talking about how symmetric 2 features are relative to another feature. And typically we're relating it to another feature, not just a surface or something like that. So if I take a look at this example, datum A is this feature over here on the left side, so roughly 2 inches. And then I've got a cut feature over here on the right side, and it tells us that it needs to be symmetrical within 3/1000ths of datum A. So since datum A is the feature, we're basically just taking the center of that feature and applying the 3/1000ths tolerance zone to it. And so this feature has to be centered around that tolerance zone. So again, concepts we've used in other ways, so I don't think that's too new, but just a matter of applying it with GD&T. So the plan for today then is trying to keep it fairly simple since we have the assembly schedule today. On page 616, you can start a new drawing based on the ANSI template. I will point out that they have the hole called out pointing to the center of the hidden feature. I notice they do that several times in this book. I've always told that you need the dimension to the center, or excuse me, to the circular shape. So I guess in theory you could rotate this 90 degrees, but then instead of a hidden line on top, you would have the visible line coming across there. So feel free to do that if you want to rotate this 90 degrees, and that way you have the circular shape. Also feel free to dimension it just like it is in the book. That's the way they've got it called out, so we'll do the same thing. So let's look at the instructions. All datums MMC unless otherwise specified. The 398 to 402 shaft, which is this little guy, is to be concentric within 0.003 with the 1.298 to 1.302 shaft. I think they give you these in a bad order because if we look at the following ones, we got to set our datums. So surface A is datum A. So here's surface A. The 1.298 to 1.302 shaft is datum B. So this is datum B. So again, we want to attach it to the dimension. Then we can go back and now take this shaft and put in the concentric relative to datum B. And then the 0.398 to 402 shaft is datum C. So again, we'll call it out there. And then the slot is symmetrically located within 0 MMC on the shaft and is referenced to datums A and B in that order. So you got your symmetric, 0 MMC, datums A and B for this slot. And so since it's calling out the slot, we'll put it underneath the slot dimension, not just pointing to a surface. We'll put it with the feature. And then finally, this small hole is perpendicular within 0.002 with the shaft. So it doesn't tell us which shaft. Since it's on this cylinder, then we should assume that it's datum C, since that's where it's located at. So again, you can attach the perpendicular under that feature. And you don't have to put in these, X's and Y's, just the standard drawing with our GD&T on it. Let me know if you have any questions.